As part of classwork today for 1993 BC4, I'm just going to give you guys the answers to some of the solutions and then go over the last page of this packet. So for the 1993 BC4, the graph of it, you guys should get a rose curve here with 3 petals, maximum petal length of 2. Plot a few points, graph it again. In the old AP exams in the 90s and 2000s, they did have you guys graph. So to find the area, we're going to say A is equal to 3 times, there's 3 petals. And then if you were to come up with the limits of integration by setting the R value equal to 2, and then also by setting the R value equal to 0, you'll see that it completes a full petal length from 0 to pi over 3. And the formula itself is 1/2 R squared. So 1/2, we could also put the 1 on the outside, 2 sine of 3 theta squared d theta, and the answer should be the value that you get for pi, so 3.142. On your calculator, you guys are going to enter this in rectangular coordinate form, so no need to be in polar form. Find the slope of the curve at theta equals pi over 4. So as you recall, dy dx should be equal to dy d theta over dx d theta. And again, the solutions are provided here as 1/2. And don't forget that you're supposed to do a substitution where x is equal to r cosine of theta and y is equal to r sine of theta. The answer for example number 10 should be E, and the answer to 11, no calculator, should be E as well. Now the focus of this video is on page 24, example number 12. This is a 2005, more realistic in terms of what you guys will see on the AP test, as all polar questions will be calculator based, and every question we have on this AP exam will be calculator based. So you see you're given an equation in polar form of a curve, and they give you a couple of pieces of information. First, they give you r as a function of theta, which we expect for all polar equations, and then they give you this expression for dr d theta, the derivative of r with respect to theta, and we'll talk about what that means. Okay, so the first question is, if we give you guys a second to read through the excerpt or the paragraph describing the situation. I would recommend that you guys do a few just checkpoints here, like plugging in 0 here into your equation to verify. It's always good to know what it is you're dealing with in terms of the coordinate points. So if I plug 0 and I get 0, if I plug pi into there, I get about negative 3.14, which is the point that you see here. So by the time you go from 0 to 3.14, we're finding the area by splitting it into sectors. The parameters already stated that gives you guys the boundaries for your limits of integration. So area equals 1/2 0 to pi of r squared, which is theta plus sine of 2 theta squared. Remember, you only need to be in polar form in order to see the graph. If you are ready to do anything calculus based like a derivative or an integral, you're going to switch back to rectangular. Please attempt to enter this into your calculator in rectangular coordinate points using rectangular coordinate form, and you should get 4.382 as the area that's bounded. So for part B, they want you guys to find the angle that corresponds to the point on the curve with the x coordinate of -2. So this is a relationship between theta and between x. Go back to your equation, and it looks like we have nothing to show for x. So what we do is we write down what we know. Well, we know x is r cosine of theta. R is given above here. Remember that key step of substituting r into your equation, so you have your function written in terms of just theta. So theta plus sine of 2 theta is r. I'm doing that substitution for this r here, this expression here, and then times cosine of theta. So now if they want me to find the angle that corresponds to the point on the curve with the x coordinate of -2, I'm going to plug -2 into here. And again, keep in mind, you guys, you do not need to be in polar form. So keeping the rectangular form from the previous problem, we're going to do an intersection point of y1 and y2, and we should see that theta is equal to 2.786. For part C, for values of theta between pi over 3 and 2 pi over 3, they're stating that drd theta is negative. What does this fact say about r? What does this fact say about the curve? Okay, so the value of r, what does this fact say about r? Well, if we think about what r is the radius or the distance away from the origin. Okay, so if this is our pole or the origin, as we look at this derivative, think of derivative as a rate of change. If it's negative, as theta increases from the limits of integration, or the parameters for the angle is pi over 3 to 2 pi over 3, as it increases from pi over 3 to 2 pi over 3, we notice that the radius value that you have here is getting smaller. So if it's getting smaller, then that means that the curve is moving closer to the origin. So as a statement, if drd theta is less than 0, then as theta increases between pi over 3 and 2 pi over 3, the radius decreases. So just this is a direct interpretation of drd theta. And then we take it one step further and answer the second question. What does that mean about the curve? It means that the curve, this means that the curve is moving closer to the origin. Lastly, for part D, find the value of theta between 0 and pi over 2 that corresponds to the point on the curve in the first quadrant with the greatest distance. So this is max from the origin. So we just discussed that the distance away from the origin is interpreted as the radius. So since we're trying to relate theta and r, we go back to our equation. We do again have drd theta. We want to find the maximum, and we have the derivative. So that means setting that derivative equal to 0. So drd theta is 1 plus 2 cosine of 2 theta equals 0. You guys have a calculator, but this can be solved using trig equations without a calculator. Cosine of 2 theta is equal to negative 1/2 if I subtract the 1 and divide by 2. So the angle measure at which I get between 0 pi over 2, negative 1/2 is in the second quadrant. That's 2 pi over 3. And if I solve for this, I get the angle measure of pi over 3, which is indeed between 0 and pi over 2. So if I were to come up with a reason or a justification of this being the maximum, I would plug in values to the left of pi over 3, such as pi over 6, into drd theta to see that it's positive. Plug in values to the right of pi over 3 to determine that it's decreasing. So therefore, there's a max here. Now, if I go back and I look at the question itself, this is a closed interval that was stated. So if they want the greatest distance, then that means that I'm looking for the absolute max. With that, your justification should also consider endpoints. So you're going to want to figure out what your radius measure is at theta equals 0. We should get a value of 0 for that. We had r is equal to theta plus sine of 2 theta. So plugging in 0, we get 0. We're going to want to plug pi over 3 in. You can use your calculator for this. 1.913. And then at pi over 2, the other endpoint, it's 1.571. So this verifies. I would have a discussion about the sign chart that we see here, in addition to the table of values, should verify that the greatest distance away from the origin occurs at pi over 3 and is 1.913. Now the point breakout is, this was plus 3 points. For limits and constant was 1. So the limits of integration and the constant value counted for 1 point. The integrand counted for 2 points, and then the answer counted for the third point. For this one, +1 for the equation. So if you guys had this equation set up, that's correct. And 1 point, and then another point for the answer for theta. For part C, it was 2 points. 1 point for the info on R, and 1 about the curve. So this was a +2 here. And then this was +2, this was +3. The last question was +2 as well. 1 for theta is equal to pi over 3, or 1.047. So this value here gave you guys a point. And then 1 point for answer and justification. So your final for this one was +2.